right, you can see a route. It is not the shortest path, but it is an accessible route that you could use in downtown Seattle. And this motivated the second project, Open Sidewalks. This one is actually focused on the data. The question is, how do you get this data when it doesn't exist already, or doesn't exist in a format that you can actually use to describe a transportation network? And to address this problem, we chose to use OpenStreetMap as our primary base for data. This is a data commons that is very different from the other data sources we've talked about today because it allows users to contribute data as well. It is a much more democratized version of these systems. And as a result, it has worldwide coverage. So it does scale up, it does have very big data, and it brings with it the ability to contribute data as well and to communicate back and forth between very, very different stakeholders. And so that project involved creating a standardized schema for how to describe these kinds of infrastructures and methods for importing data to say, we have this SDOT data, it's not in the right format, but here's how we can get there. Cool. And if I have time, can I do a quick demo? Do I not have time?
Demos at the coffee break.
Demos at coffee break. Okay, great. Thank you.
I've been told that our closed captioning cuts off, and so we want to try to get everybody in there, but I'm sure that you'll be able to see a great demo from Nick soon. Next, we have Ali Ghazemzadeh, who's a PhD candidate at the University of Wyoming, and he's here to talk about research to deployment using Sharp2 safety data.
Hello, everyone. So today I'm going to talk about the driver performance and behavior in adverse weather conditions using the Sharp2 naturalistic driving study. I would like to thank our team, specifically Dr. Mohammed Ahmed, my advisor, for his unlimited support and guidance. So among the 8 IAP projects, University of Wyoming is the only university working exclusively on weather information and weather-related trips and drivers' behavior and performance in adverse weather conditions. So let us start with this question. Why is it important to understand the driver behavior? Transportation researchers have many important findings, and sometimes they require basically society involvement, starting a behavior, stopping a behavior, changing a behavior. Most of the time they don't succeed, and to me this is because they don't use the right language. Using the naturalistic driving data can help us to better understand the driver behavior so as to use the right language. Let us look at the current situation, which to me is like a war situation. Every year, millions of us lost their life and are killed and injured in car crashes. Specifically in US, we have more than 30,000 people, fatalities every year. The role of weather, what's the role of weather-related crashes? We know that about 25% of crashes are weather-related. Adverse weather conditions can impact the roadways by influencing the surface conditions, driver behavior, vehicle performance, and visibility. And this research, the one that we are working on, is kind of different from other naturalistic driving studies, and I'm going to talk more about that. The picture that you can see here is the I-80 that we had a pilot crash in 2015. And we have a VSL system in this corridor, basically, and we are going to incorporate the results from the Sharp2 project into final countermeasure, which is updating the current weather-based VSL system, and not only that, providing information for advanced traveler information system. The other aspect that we can use the results from this project is we can get more insight into connected vehicle weather application. So just a quick talk about the Sharp2 project. It has 2 main components. RID, which is Roadway Information Database, contains the roadway characteristics of the traveled routes. NDS, which is the naturalistic driving data, 3,500 participants were participating in this project. So if you have a specific driver traveled a specific route, you can get the basically roadway information of the traversed routes using the RID. Our main research questions are here, and the first research question is that can we really identify the weather-related trips using the 5 petabytes of data? And that's why I mentioned our project is kind of different from other naturalistic driving studies because the weather information is not provided by default in the naturalistic driving data. So we had to come up with our own methodologies to identify the weather-related trips. If we succeed on that, we can actually work on those trips. By tracking those trips, we can better understand the driver's behavior in adverse weather conditions, and we can basically find the best technique to find the results we are looking for. So for the first phase of this project, we just focused on rain. We requested 50 trips in only rain weather conditions. In phase 2, we focused on all the weather conditions, and in phase 1, we requested another 100 matching trips. When I'm saying matching, it means the same driver, same route, and same vehicle. We faced with lots of challenges for data acquisition and preparation, and I think I don't have time to talk about those. The lesson learned from here, it's challenging to identify and track the weather-related trips, but it's doable. And there is significant difference between drivers' behavior and performance in adverse weather and clear weather conditions. So these are the list of publications that if you're interested, you can go and just check them out. The most recent one, the driver's lane keeping ability in inclement weather conditions. And also, I would be happy to answer your questions via email. So my email is down there. Thank you very much.
Great, and next we have a no slides person, so this should be quite efficient. We have Kristen Tupty up here again. As you will recall from the morning, Kristen is a research assistant professor at Portland State University. She's also on the steering committee for the West Big Data Innovation Hub. You just get this beautiful background.
I have a beautiful background. All right, thanks, Meredith, and thank you for having me here. So I'm going to talk to you today about two quick things. So one is Portal, which is a transportation data archive that I direct. And I think it's of interest to this crowd because it has a really incredible source of data. And the second thing I want to talk about is